What's going on, guys? Again here. Now when we have our set file and rank masks, we can now already go for initializing this file masks and rank masks and all these arrays, serving the purpose of evaluating the pawns respectively. But before that, I just want to add one little thing that I forgot to do in the previous video. We actually would have a different arrays for white passed pawns and for the black passed pawns, because they're literally moving to the opposite direction. So that's the idea, and they would be different respectively. So here I just want to say this white passed pawn masks, and here this would be respectively the black and black here. Okay, now I just want to grab this loop over the files and ranks, which we would be making use of all the time, and paste it here. So first we would like to initialize let's say file masks like this. So just want to have the same number of stars. Okay, it's probably the same. Yeah, perfect. Okay, so again, let's start with initializing the square. So initialize square, current board square, to be calculated from the rank and files like we usually do. So in square would be equal rank multiplied by 8 plus file. And what we want to do now we want to actually initialize our file masks with the corresponding file, and same for ranks. So initialize file mask for a given square, for a current square. And so how this is called, so I'm referencing that now. I'm referencing the file masks here indexed by the square that we've just created, and this would be bitwise OR equals, so we have bitwise OR in this with the return value of this set file rank mask, and assuming that we actually we are actually setting the false. In this case we need to say -1 for rank, and for the file I just want to send the file itself. So quite pretty easy. And just for the debugging purposes, I just want to let's print the square, and so this would be like square to coordinates and square, sorry, it's not a function, it's an array, square like this. And also I want to print the bitboard, the resultant bitboard for every single square. So file masks indexed by the square, and this should print the file masks for all the available squares we have. So let's try to compile and run the code. So say make debug, and if it compiles, run the BBC executable. Okay, so let's have a look. Okay, so we got this for H1, for G1, F1, E1, D1, C1, B1, A1, good. And now H2, and literally the mask for H2 is exactly the same as the mask for H1, but we don't care. We just it's a little bit of a duplication, but it's the easiest way of initialization. So we're having this masks literally for all the squares on board up to the 8th rank. So just scroll a bit down, a bit upwards, B8, A8, and here we're done here. So I hope this is quite pretty self-explanatory what we've been doing here. So with this idea in mind, so I don't really want to print these coordinates anymore, and also I don't want to print this. So let's grab the code and now make the same for the rank masks. And as far as we're dealing with the files first, the order is like just like we need. Okay, so here it's the same, apart from here we say the rank masks, and we actually want to send the rank as the limit of what to return back. Okay, so square to coordinates, and I want to print the rank masks. So let's have a look. Now should be printing all the ranks. So let me just make sure. So is this correct? So H1, G1, yeah, F1, E1, D1, C1, B1, A1, and then H1. So yeah, it's a bit different order of how they are printed, but it doesn't really matter that much because we're having this ranks for every single square on a given file. So like the third and so on. So it's the idea is the same. So we're having this ranks being initialized for every single square we need. Okay. Yeah, just I'm a bit confused because when I was debugging this, probably I did this in a different order, like files were first and then ranks. The output was a little bit different, but it doesn't change the idea generally. So not a big deal really. Okay, and now we will go for initializing our isolated masks. So I'm grabbing this filemasks because they would be quite pretty similar to what we need to do. So initialize isolated masks. Okay, somebody's riding around the street trying to sell the potatoes. I hate this environmental sounds. Okay, sorry guys for being distracted. Okay, I probably just closed the door because this is annoying me so much. Hold on a sec. Okay guys, I'm really sorry for being distracted, so let's get back to our isolated masks. Okay, so here we want find filemasks1, and also so now it's not the file masks, it's isolated masks. So file-1 and file+1. And now how this is supposed to be look like. Isolated masks, so let's have a look. So here is the isolated mask for the pawn on h1. So we don't have the right bound because it's the board edge. So if there are no pawns, there are no white pawns on this rank, on this file, on this G file, this means that the pawn would be isolated. Well, obviously we won't ever have the pawn on h1, but it's the same like we've been initializing our pre-calculated attack tables for all the pieces, because it's just a matter of looking through all the board squares. Even though we're not going to be using this, but still this is just available. Now the pawn on g1, this is the mask, and now moving on, and then pawn on a1, this is the mask, and then we go into h2, so it's the next, and the same. So it's almost the same like we had with the file masks. The difference is that we actually do make use of our we're just doing this kind of twice, just to distinguish this isolated masks. So if pawn say e6, so here, so if just we don't have like It's the same, by the way, for both for white pawns and black pawns, because it's just a matter of what pawn bitboards to bitwise and our pawn in the evaluation. So say for black pawn we would be bitwise ended with the black pawns, for white pawn with a white pawn, just to make sure that if this bitwise end operation with a white pawn bitboard would actually detect some pawns here or here, this means the pawn is not isolated, and if it doesn't detect anything, that means the pawn is isolated. But obviously I would be demonstrating this on examples with setting up the FEN appropriately on the board, so we would be able to see how the scores are changed when we're having the isolated pawn or things like that. So hope that's quite pretty self-explanatory. Okay, hold on a sec. The only thing, what? Oh, this is going from the previous. Okay, so we don't really need to print this stuff here, and yeah, probably like by the end of this video I would actually, let's make it now. I don't really want to have this print statements in the code. Okay, isolated masks. Okay, and now we should go for our white and black pawn, black passed masks. And with the passed masks, it's going to be a little bit more complicated, but not really that much. So I just grabbed this isolated code here, and okay, just hold on a sec. It's probably like this. So here we'll have, let's start with the white passed masks like this. Okay. Okay, so it would be consistent of two parts. So the first part is like with the isolated, but also we need to have the file itself. So what have I done? So if you just have a look how they look like, this is it. But when it comes to say H2 and so on, so this should be we need to reset this, and then we go to say H3, we need already to reset this too, and so on. And well, the overall idea is, well, let's say the pawn is here, all this are zeros and all this are ones. So I'll demonstrate this just right in a moment. It involves a little bit tricky indexing, so I would rather use my existing code to make sure that there won't be any errors. But the idea is then when we would have been bitwise ending this this entire mask with opponent's pawns, so with a black pawn. So if no black pawns here, then we consider that this pawn is actually passed. So it's quite pretty simple. Again, it would be shown on the particular example. So okay, yeah, let me actually just reference this code that I've written before, just to make sure. Black masks, white masks. So it's quite pretty simple, but it's a bit tricky to debug to make it working properly. So just add some commentaries. So here we want to reset, let's say redundant bits, and here loop over redundant ranks. So by saying redundant, I mean those that are not involved into that are not actually involved. Oh, let me just show you this, guys. Just it's easier to it's a bit different. So white past masks. So let's have a look. So for the pawns on the first rank, even though there won't be such a situation, it still remains the same. But okay, hold on a sec. What? Hold on a sec. I just don't get it. Why it doesn't change really? Oh, I'm still printing the isolated masks, by the way. And oh my god, what have I done? What have I done? I don't need to... Sorry guys, that's the dark side of copy pasting. So this would be obviously the white past masks. So make sure I don't do anything wrong with the isolated masks. So actually I want to keep the isolated mask as is. Excuse me. Oh. Yeah, so you see like now it just gets rid of unnecessary bits below. So here we have the square E3. Okay, hold on a sec. Hold on a sec. It seems like I just found a little bug here. Actually, it should delete this one as well. Okay, guys, sorry, just found a little bug in my code. Well, before that, I just want to make sure that still my isolated code is working properly. Okay. Yeah, it was a little bit wrong what I did. Okay. Yeah, the isolated one seems to be working fine. Working okay. Okay, and here, oh my god. So 7 minus I. Okay guys, so sorry, I just paused the video. I need to try to I'm using trial and error method in these like cases, so just hold on a sec, I'll be back in a moment. Okay guys, so we need to say not 7 but 8 minus rank, so now this is how it's supposed to look like. So for the H1 here, everything that goes upwards are the bits to bitwise and the opponent pawns with to get whether this pawn on G1 is isolated or not. So the pawn is here on F1, so on, and this is it. And just to make sure it's working kind of properly, I want to scroll up until, so it should end up with F7, C7, and now this should be starting from H8. This should be empty. Yeah, this is exactly the behavior I intended to have. Good. Okay. So D6. Okay, so white pawn's going upwards, black pawn's going downwards. Okay. So for the black passed pawns, this pattern would be the same apart from black and well, we need to change all this to black. And okay, black pawns here. Okay, so, and yeah, just sorry guys, I just want to reference the exact, so we're not doing anything to rank and not doing anything to I. probably will need still to adjust the rank, something like +1 or something. Okay. Excuse me. Oh, I need to bring the black. Oh, save. So this is H1. Yeah, so okay, H1. So this shouldn't be actually printing, and the H1 it shouldn't be printing anything. So, well, I'm not sure. Sorry guys, just it's too hard for me to imagine this in my head, so just using this trial and error method. Okay, so probably rank +1 is about to be working. Let's see. So starting with H2, okay, H2, and this bits, G2, this bits, okay. Then okay, we go into H3, so on, and we should end up with G8, okay, F8, C8, and A8 here, which is just fine. Yeah, okay guys, so congratulations, we've just successfully initialized our masks for isolated and passed pawns for black and white, which means that already starting from the next video we would be capable of applying this either bonuses or penalties for this kind of masks, bonuses or penalties for either isolated or double pawns, or you know, like passed pawns. The only issue here at the moment that the particular weights that the particular penalties were supposed to be given to the evaluation based on this pawn types or bonuses, if this is the passed pawns, should be tuned actually, and I didn't yet work with neither isolated nor passed pawns. I just tried this with the double pawns, so I will now go for some tests to make BBC playing versus TSCP to make sure like how exactly it's going to be playing, so just to fine-tune those variables. And we didn't yet specify them. I will initialize them starting from the next video, and when when actually comes to a decent play, we'll then embed them. And also another idea that these file masks could be used in order to obtain in order to gain some bonuses for rooks and queens while being on either semi-open, open, or open files, which is also a good positional idea to have in mind. Okay, and then we can go for some other tricks like piece mobility, king safety, well, at least the very basics of those. And starting from that, the engine should already be playing kind of better chess. I would also probably change this, in particular bishop scores, because it doesn't now go for the real pass opening at all, because it doesn't have this the positive score for this B6 square, which is not really that great. So probably just having some better score here to make it playing real pass, because it's quite pretty good opening that people play until now, until today, and some minor things. Well, I'm not sure about changing the value for fianchettoing the bishops, because I really like the style when the bishop is getting when the bishop is fianchettoing here. Fianchettoing, not sure how to pronounce that. Okay guys, so this is it from my side. Now I need to make some work on fine-tuning this bonuses and penalties on the pawn structure, and probably we will be watching the very first game of BBC playing versus TSCP with those adjustments, because already with only these adjustments it would give no chance to TSCP to win actually. Well, at least if I did everything correctly. Okay guys, so this is it from my side. I hope to see you oh man. I hope to see you in the next series, in the next parts. Oh my god. Have a good time, guys. Take care.